Hey guys, how's it going? I just wanted to make another video for you about normal distribution. And I also wanted to remind you that you do have your assignment due on Wednesday, the 21st. Less than a week away now that it's the 15th, Thursday. We do have an exam as well the following Tuesday on the 27th. I have talked to Claire, Shuking, and Sarah, and we're trying to get our hours together for that Tuesday, and we'll probably be there for a couple more hours on that Monday just to help you guys better prepare for the exam. Normal distribution is going to be on the exam. Sampling will not be on the exam, so chapters 1, 2, and 3 I wouldn't worry about. Just know how to find the standard deviation and the variance and etc. Alright, so in my last video I talked about what normal distribution is. I talked about the empirical rule, the 68, 95, 99 rule applied to normal distribution. And I worked through a little bit of one problem regarding normal distribution. This video is going to be working through another problem and going over percentiles, because I know that in class today you guys went over percentiles and a lot of you were confused about that, so we'll go through that. But first let's start on another problem. Let's go to example, let's see here. Let's go to example 6.8 on page 171 of your books. I'm just going to write up here that this is normal distribution. Alright, so the problem says the ACT, composite scores Y in 2009 are believed to be normally distributed with a mean score of 21.1 and a variance of 26.01. So after watching that first video, we can rewrite this. We can say X, or we're not going to say X because it's giving it to us as Y in this one. So we're going to say that Y is normally distributed with a mean of 21.1 and a variance, sigma squared, of 26.01. There are going to be scenarios, and we will go through another problem with this, where Professor Onia just gives us this portion right here and tells us to test for other X and Y values. So it is possible to just see what's in this highlighted square on an exam and be expected to know what that means. So if you aren't really understanding what that means yet, maybe go back and watch that first video again. I know it's in the first maybe minute or two. So we're being asked, what is the probability that any student who took the ACT composite in 2019 scored, we're going to say probability that what's the probability that A is scored between 12.8 and 30.5. Now remember in the last problem I taught you guys how to analyze this. So we're looking at between 12.8 and 30.5, and we're going to look at our mean and say, okay, where does our mean fall in this area? And it falls almost smack dab in between 12.8 and 30.5. So the probability that a score falls in between these two values, it's going to be pretty high, is what we can expect. But let's do the problem and see exactly where it lies. We're going to come down here a little bit. All right, so we're going to break this up into a couple of steps. And step one is to identify the equation. So the equation that we're going to need is that z equals x minus x bar all over sigma, our standard deviation. So up here, and instead of calling these y values, we're going to call them x values to avoid a little bit of confusion. So if we go up here, we see that we have two values here. And these values are what we're going to be plugging into the equation. So if we have two values that we're going to be plugging into the equation, we're actually going to have to write out that equation twice so that we can plug in each of the values. So we're going to come back over here and we're going to say that z equals my x minus my mean, which is 21.1, divided by, and we're going to have to do some math here. We'll find the square root of 26.01, the variance that we were given, is going to be 5.1. And notice this does not have a square at the top of it, so it's just sigma, just the standard deviation. We can't use the variance there. Now that we have our skeleton equation and we can plug values in, I'm going to erase this x, and I'm going to put in one of my values. I am going to put in 12.8 in this one. And I'm going to come down here and do it again. I'm going to say z equals x minus 21.1 divided by 5.1. And I can take this x out as well, and I can put my other x value in, 30.5. Now that we have those, we can just solve for z. We have everything that we need on this side of the equation to solve for the z. So when we do all of the math for those and we find all of our answers, we are going to find that our top one is going to come out to be negative 1.63. And our bottom one's going to be 1.84 after we do all of the math. Now remember what I said in the first video, we might have, you know, after this 3, we might have 1, 0, 2, 5, etc., etc. I'm just making that up. But we only want these 3 digits right here. So we can just round this third digit. We're going to round up or down to this third digit, and we're going to get rid of everything back here. Because on the z table, we only need 3 digits. And that's exactly where we're going from here. We're going to go to the z table. And I know it's pretty tough to show you guys exactly how to use the z table on here. I did try in my last video, but I am going to turn my book now to the z table. And what I'm going to do is I'm going to find both of those values in the z table. And if I remember correctly, the z table is going to be on page 523. And I'm going to try to kind of verbally walk you guys through how we're going to do this. So this 1.63 right here, we're going to find on the left-hand column of the table, the farthest left, where at the very top it says Z, we're going to find just the two digits, negative 1.6. And negatives are very important in what we're doing right now. So negative 1.6. And that's going to be on page 523. It's the fifth one from the bottom. And then what we're going to do is we're going to look at the top and we're going to see those 0, 0.01, 0.02, 0.03, etc., etc. And we're going to go over on the Z table until we see 0.03, which represents our third digit. So we're going to go over to 0.03, and we've got 0.0516. This is the probability associated with this Z-score. And we'll do the same thing for 1.84. 1.84 is going to be found on page 525. 1.8 is the top one, the very first column. And we're going to go over to the last number, 4, and we're going to see 0.9671. This is the probability associated with 1.84 as a Z-score. Now I know what you're thinking, well gosh Ariel, I've got two Z-scores, I've got two probabilities from those Z-scores, what the heck am I supposed to do with these? The answer to that is you're going to make a normal distribution curve. And remember I said we're going to be making a lot of these. So here's my normal distribution curve. And I'm drawing this, it's the normal distribution curve with these isn't as important as it is with percentiles, but it does help to visualize this. So I'm going to draw a 0 here. And up here, I'm going to put 0.9671. That means that 96.71% of my data lie all the way down on this side of the normal distribution curve. And then the opposite lies up here. Now my other value is 0.0516. So 0.0516, we're going to draw a line down here. 0.0516. What that means is that 5.16% of the data lie below this point. And to help us along a little bit, we're going to write the X values. We're going to say, okay, 90.9671% is associated with the X value of 30.5. Up here, we got this probability from that score, from that X value. And down here, we're going to put the 12.8. Now the question is asking us to find the probability that the scores are going to be between 12.8 and 30.5. So what they're asking for is the area in here, in between those two. So what we're going to do actually is we're going to take that 0.9671 and and we're going to subtract 0.0516 to get the area in between the two. And that is actually going to give us 0.9155. And this is going to be the probability of students scoring between 12.8 and 30.5 on their ACT. Well, let's go on to B. I'm actually going to go over here. Sorry if I'm making any of you guys a little bit dizzy. So B wants to know what the probability is of students scoring greater than 16.5. Or X is greater than 16.5. And I know in the last video I talked about the rule with greater than or less than for this. And now for this one, I'm going to show you guys how to apply it. So we're going to do the same thing we did for the last one. We're going to say, okay, I know that 16.5 is going to be the X value that I plug in. So I'm going to say that Z equals, and I'm going to say X minus 21.1 divided by 5.1. And we're going to do the same thing as we did in the last one. We're going to pull that X out and we're going to put 16.5 in. Now I can do the math. I can say, okay, what's 16.5 minus 21.1? And then I'm going to divide it by 5.1. And I am going to get negative 0.9. And I'm going to add a 0 to the end of this just so we know that zeros are digits. So when we need 3 digits, I mean 3 digits. You put a 0 in there at the beginning, a 0 in there at the end, so that we can find it on the Z table. And that's exactly where we're going from here. We're going to go to page 523. And now this one's kind of funky. We're going to go down the left column. And we're actually going to turn back to page 524. And we're going to go to the third one from the top, negative 0.9. And we're going to go over 1 to 0, where it says 0 at the very top, on the top row. And we see that the score associated with this, or the probability, excuse me, associated with the Z-score is 0.1841. But can we stop there? Remember in the last video I told you that the Z-table is set up to find less than, not greater than. So anytime, I'm going to put this in a special color, anytime you see the words upper, greater than, or above, you're going to follow this next step that we're going to take. The road to get to the probability is going to be the same. We're going to start out with the equation. We're going to plug our X value in. we're going to get our z-score, and we're going to plug it into the table to get our probability. But now what we're going to have to do is we're going to have to say that, okay, the rule for probabilities is that I can subtract one probability from one and get the opposite probability. And so when I say that the z-table isn't set up to find anything above, that doesn't mean that we can't find anything below and subtract it from 1. So what we're going to do is we're going to say, okay, 1 minus 0.1841 equals, let me do a little bit of math, 0.8159. This is going to be the probability of a student scoring greater than 16.5 on their ACT. So remember the rule. Remember the upper, greater, above, we're subtracting from 1. Now, we're going to do part C. Less than 23.9. So we're going to say x is less than 23.9. So what we do is the same thing. We're going to say z equals x minus 21.1 over 5.1. Remember that this one right here, that's going to be our mean, and this one is going to be our standard deviation. So now we can take the x out and put 23.9 in and do the math. And for a z-score, we're actually going to get 0.55. So now we're going to take that 0.55, we're going to go to the z-table on page 523, and we'll have to go to 524 to find this one. I'm going to find 0.5 on the left-hand side, and I'm going to go over until the top says 0.05. And now I found it, it's going to be 0.7088. And now because it's saying less than, and I only have one x value to plug in, I'm done here. I can say that the probability of a student scoring less than 23.9 on their ACT is 0.7088, or 70.88%. Awesome. So now that we finished one of those problems, we're going to start on something a little bit new. We're going to go over to percentiles. Now, the equation shown in the book is similar to what we've been using, but I'm going to just tell you to remember one specific equation here, and this is the one we're going to be using. It's going to be mu plus our sigma times ZP going to equal our x sub p. So what are all of these fun symbols? We know mu and we know sigma. Mu is our mean, sigma is our standard deviation. But what is this z sub p? I am going to do my best at drawing the distribution table again. I'm going to say, we have Z here. We have 0.1, 0.2, 0.3, 0.4. And I've got probabilities in here. I've got 0.01. And this is not the same as a table in the book. I am just making this one to show you guys how to use the table to do this. So Z sub P is telling us to use the Z table the opposite way. So what we've been doing with the Z table is we've been using Z-scores, which are found here and here, to locate a probability associated with that Z-score. Well, now we're going to do the opposite. We are going to be given a probability or a percentile or a percentage. One thing that we can do with percentages is we can convert them to probabilities. We can say, okay, I'm looking for the 70th percentile or 70% of the data. Here's my decimal point. I'm going to move it 2 to the left, and I've got 0.70. This is a probability. I can find it in the body of the table, along with all of its other probability buddies. I cannot, however, look at these numbers. And it doesn't, it's, you know, I know that this is a decimal. It does look kind of like some of the Z-scores, but this is a probability. I have to look at like values. That's why I'm going to look in the body of the Z table and not along the edges, not in the skeleton, I like to call it, where the Z-scores are. So let's say that I'm given I want to know the 40th percentile. I'm going to convert it to a probability and say, okay, 0.40. And I'm going to take it and I'm going to find it in the table. So it's right here, 0.4. So now what I'll do is I will find the Z-score for that probability. So I'll say, okay, the first number is going to be 0.2. 0.2. And then I'll go up to 0.01. I'll throw these together and I'll say my Z-score is 0.21. Same thing if I'm given the 20th percentile. I'm going to move it over, say that it's 0.2. I'm going to find 0.2, which is right here, and I'll find the Z-score by going here and saying, okay, 0.1 is my first number, and 0.04 is my second number. So 0.14. This just shows that we can work forwards and backwards on the Z table. So we can get Z-scores from probabilities, or we can get probabilities from Z-scores. So we've got this equation here, and we talked about what Z sub P is. I am going to go through a problem with you so we can actually find out what our answer is going to look like, because our answers are going to be larger than the probabilities that we were solving for before in our other problems for normal distribution. There's a reason for this. So if we go to page, let's see here. All right, let's do example 6.14 on page 175. So Y, the number of days of deployment of a soldier in the war front, is believed to be normally distributed with a mean of 275 days and a variance of 85 days. Obtain the number of days of deployment a soldier would stay at the war front to be in the, and we're going to do A, the lower 75th percentile. All right, so when we're looking at this, the first thing that I want you guys to get into the habit of doing is to convert this 75% to a probability, to a decimal. So we're going to convert it. You can either divide by 100, move the decimal place over to the left 2 spaces. Just know that this is going to be 0.75. And we know our equation. We know that mu plus our sigma times our z-score associated with the probability, or the proportion, equals x sub p. And we're given the mean. We know that the mean is 275 days. So we'll come over here and we'll say x is normally distributed with mean of 275 days and variance of 85 days. I'm going to take the square root of that 85, and I am going to get 9.21944. So now we're going to come over here and we're going to plug those values into our equation. So our mean is 275 plus our sigma, 9.21944, times our z sub p equals x sub p. Now let's talk about this z sub p. We learned how to find it on the table. We know what's the z-score associated with the probability. But what's the probability that we're given? It's actually in the problem. It's going to be whatever percentile. Once we convert it to a decimal, we can find it on the z-table. So that's what we're gonna do. We're gonna take that 0.75 and we're gonna go to page 523. And we are going to find the closest value to 0.75. And there is always going to be one that's closer. So we're gonna look in the body and find 0.75. I'm on page 524 for anyone who's going along with me. And I've got 0.7486 and 0.7518. So when you're thinking about this, I know some of you want to go with 0.7518 because it looks closer than 0.7486. And you might be right here. It is going to be that 0.7486 on page 524. So now we're going to trace to the left to 0.6 and trace up to 0.07. So our z-score is going to be 0.67. So we're going to come over here and we're going to erase this. And we're going to plug in 0.67. So now when I do all of the math, I'm going to get 281.1771. Now what the heck does this mean? This is going to be x sub p. But what does it mean? Well, to determine what it means, we're going to come down here and I'm going to draw a normal distribution curve. I'm going to go and I'm going to say, okay, if I draw a line right here, 70% of my data is going to be below the line and 30% is going to be above the line. But what I was solving for there was the mark that separates the two. So I want to know how far this way I can go before I'm in the upper 30th percentile. And I want to know how far this way I can go before I'm in the lower 70th percentile. And that value is what we found, that 281, and I'm going to round it, I'm going to say it's 281. 281 is that tipping point. So if I'm going this way and I hit 281, as soon as I go to 282, I'm in the top 30th percentile. But as long as I'm staying under 281, I'm in the lower 70th percentile. I hope that makes a little bit more sense for you guys. All right. Let's do, I want to do one more with you. This is not in the question, but we're going to go through it regardless. We're going to do the upper 25th percentile. Now I have to convert that 25% to a decimal, 0.25. But I know earlier on I had told you guys that there were 3 words that I want you to look for: upper, above, and let's just see what that third one was. Can't even remember what I had for breakfast. Let's see here. Where were 3 words? There we go. Upper, greater than, and above. Right here. So when it's saying that it wants us to find that upper 25th percentile, we convert it to 0.25, we have to take that 25th percentile, that 0.25, and we have to subtract it from 1. Because remember, the table is not set up to find anything that's greater than, upper, above. It's set up to find lower than, less than, lower percentile, etc. So now what we're going to do is we are going to do the same thing. I like starting off by finding this bad boy on the table. So we have already done the lower 75th percentile. I'm going to walk you through it again. Our value was 0.67. We plugged it in, 275 plus our standard deviation. 0.67, and we got that 281.1771. One cool thing about this is that if he asked you for the lower 75th percentile and the upper 25th percentile, the answers are going to be the exact same thing, because that upper 25th percent, you're going to have to convert to the lower 75th to find it anyway. It's just asking you to, and I'm going to find that. It's just asking you, oh hey, I did, whoops. This is going to be 25. Sorry, guys. All right. So instead of finding the lower 75th, we were told to find the upper 25th. But it's the exact same thing. We just converted it to the lower 75th and we solved for it, but this value is still the border. So it's the same answer. Alright guys, that's all the time I have for today. I do plan on, once we're getting to, let's see what we got going on next. I don't know how far through chapter 6 he's planning on going, but chapter 7 and the central limit theorem, I think you might touch on next. So if you're wanting to read ahead, I'd start on chapter 7. Otherwise, thank you very much for tuning in.